How do smartphones connect to 5 grams base stations hundreds of meters away? And how do automotive radars detect obstacles with high precision? The secret lies in RF PCBs, which are specially designed to handle high-frequency signals from hundreds of MHz to tens of gigahertz. Widely used in 5 grams, radar, satellite communications, and other applications. At high frequencies, traces on ordinary PCBs acting like antennas, causing signal radiation, reflection, and interference, making normal operation impossible. The difference between RF PCBs and regular PCBs is like that between a high-speed racetrack and a country road, requiring extremely demanding materials, designs, and manufacturing processes. Key points. 3 core challenges: signal loss, impedance mismatch, and crosstalk interference. Standard FR4 is not suitable. Low-loss specialized materials such as Rogers, TFE must be used. Design rules: short and direct routing, no 90 angles, continuous ground plane, isolation between RF and digital sections, high manufacturing precision, tight control of trace width and layer alignment, plus TDR impedance testing. RF PCBs are critical for the stable performance of wireless products. Their importance will continue to grow with the development of 5 grams mmWave and 6 grams